In your opinion, how are robotics and drones transforming infrastructure inspection, construction, and maintenance, and what advantages do they offer over traditional methods? And do you have any examples you can share with us?
When we think about value, we kind of categorize it into 4 key buckets. So safety comes up as number 1. What can we do to either minimize or eliminate the need for rope access, scaffolding, bucket trucks, lane closures, and remove our people from harm's way? We look at it as far as data integrity. So how can we improve the deliverable to our client? And how can we improve the deliverable from the field to our engineers that create and generate our reports?
Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. Did you know that traditional infrastructure inspections can cost up to 10 times more and take weeks longer than using drones and robots? Manual inspections of bridges, tunnels, and high-rise structures aren't just costly, they also pose serious safety risks. In today's episode, we're diving into the future of infrastructure inspection and maintenance with Miles Kilcourse, Director of Robotics at Gedeon GRC Consulting. He will be talking about how robotics and drones are revolutionizing site monitoring, enhancing safety, cutting costs, and optimizing decision-making through automation and AI. I'm your host, Nick Heim, and this is the AEC Engineering and Technology Podcast. With that, let's jump into today's episode. It's now time for our conversation of the week with Miles Kilcourse. Miles, thank you so much for taking the time to join the show, and welcome.
Thank you. Thank you for having me.
So, Miles, as we were talking about earlier, right? I'm a show. I think I've talked to robotics people, I've talked to AEC people, but I haven't yet had an interview with somebody who is so deeply involved in robotics while working for an AEC firm. So I think this is going to be an interesting conversation. I just want to jump right into it. So, Miles, can you start by telling us a little bit about yourself and what inspired you to pursue a career in robotics and drones?
Actually, early off, as I was kind of figuring out what I wanted to do for work, I was really interested in the film industry. Drones were just barely at the infancy stage. There were no requirements to fly them. I happened to be walking past a film set that gave me an opportunity to kind of jump in with some equipment that I had bought. And that really skyrocketed in terms of an opportunity for a career. As I spent more time in that industry and understood the long hours, the excitement, the travel, I wanted to kind of formalize my understanding of the equipment that I was working with, that I was really passionate about, and found that love, more so for what could be done when you take a camera or a sensor and you put it in front of something that has no limitations in 3D space. So I actually went back to school and completed my master's in mechatronics and robotics engineering, where I really understood and gained valuable insight into robots that weren't just flying. So, what could you do putting these same or similar or actually wildly different sensors on things like underwater robots, ground-based, whether it's legged or wheeled, and look at combining those to really create a comprehensive approach to whether it's inspection or scanning or regular monitoring. And had actually been working with my firm Gedeon for many years on and off as a contractor, and as my degree was coming to completion, I had the opportunity to come on board full time and take the knowledge that I had gained both in the industry prior and on previous projects and my newfound industry knowledge from the robotics side, and really form this department into not just what it is now, but the direction that we're heading, really shifting our industry forward and delivering that value of both everything that I've learned and everything that I learn on a day-to-day basis being a part of an AEC firm, from our structural engineers, our civil engineers, our traffic engineers.
Which I think is a really cool story, Miles, because you essentially started in an industry that is maybe somewhat related to what we do, found your passion, went back to school for it, and now you're in what sounds like to me a pretty forward-thinking firm heading up a robotics department to essentially change the way that, I'm sure that things have been done for a while, and there's definitely new ways of looking at it based on your experiences and what you've learned.
Absolutely.
So, as a segue into my next question, Miles, so In your opinion, how are robotics and drones transforming infrastructure inspection, construction, and maintenance? And what advantages do they offer over traditional methods? And do you have any examples you can share with us?
When we think about value, we kind of categorize it into four key buckets. So safety comes up as number one. What can we do to either minimize or eliminate the need for rope access, scaffolding, bucket trucks, lane closures, and remove our people from harm's way? We look at it as far as data integrity. So how can we improve the deliverable to our client? And how can we improve the deliverable from the field to our engineers that create and generate our reports? Which is really important because that changes the way that, as a small firm, we're able to take on whether it's larger scope work or larger volume of work because our field efficiency and our office efficiency are really improved. All of that leads to reduced costs across the board. We're spending less hours out in the field. We have less operating expenses related to rentals for bucket trucks, significant days of lane closure, long hours in the office, which our clients really love. And on top of all of that, if we're cutting down the number of hours, we're shrinking timelines for our clients. Whether that's, performing a bridge inspection where you're dangling a bucket truck over the side of a bridge over water or using a barge and having lifts on top of it, those take a lot of time, and there's a lot of single points of failure that can really cause harm to the staff that are out there. Or building inspections where you're either using rope access to get even a small sliver of what is really happening on the building envelope. And most recently, a project that we did was to perform inspection inside some major ductwork in New Jersey. And our goal was to access areas that are completely inaccessible to people. The cost of either building scaffolding up 40, 50 feet inside of these ducts or using rope access along very narrow edges, which require really an insurmountable cost to be able to provide that safety to that rope access team, or complete inaccessibility. There are turning veins in the duct that you can't kind of like sneak your way through, or really shouldn't, that we're able to complete a 100% inspection in a matter of a week, which would typically take 2+ weeks just to build the scaffolding, let alone do the inspection. So that is a major change in safety. It's a major change in data. All of our photos are put onto a point cloud, so we know exactly where within the infrastructure any deficiencies that we found were, which made the entry into those spaces and the permits required to do so really efficient. Obviously, we saved a bunch of time, and we ultimately delivered value in the form of cost savings as well.
It sounds like to me, Miles, you're essentially taking what sounds like an innovative spirit applied through, right, robots, whether on the air or in the ground, and different applications and different asset types, that has a positive effect on your company's bottom line, culture, right, which makes for happy employees and happy clients.
Yep. Yeah, and our engineering teams really do enjoy this value because whether it's spending less time in a bucket truck, a lot of engineering work on infrastructure happens at night, where you have higher rates of distracted or intoxicated or tired driving. You have lower visibility, and all of those lead to significant safety risks. It also means that you have to then carry additional equipment, whether it's a light on your hard hat, photos come out blurry because you don't have sufficient lighting. And while it's not always the case that we can do our operations during the day, just due to traffic flow, we bring all of that on our drones. So it's like having the pad and pencil, the ruler, the lights, the camera, all of that, even things like thickness gauges and taking different types of measurement, whether it's the paint coating that's remaining or looking at section loss in steel beams, we're able to do that safely from the ground. And so, again, the less risk that you have while you're in the field, and the more we can put our equipment into those environments, the safer our people will be. And that's really high value, not just to us, obviously. We care about our engineers, we care about our people at Gedeon, but it's a really core value of all of the firms that we work with. Safety is always number one in the conversation, and it's actually the value that seems to drive the most interest from our clients. Obviously, the bottom line as well, but safety improvements is really a hard to quantify risk value that most people, are reaching a stage where they're not willing to accept it anymore. And that's a really positive change, both for my department as well as the industry as a whole.
Absolutely. And Miles, I have to imagine as much of the benefits are obvious to you, me, and anyone that might be listening, there's going to be challenges. So can you speak to what some of the biggest challenges AEC firms face in adopting drones and robotics? And building off your point on safety, do you have any more examples or advice to offer on that specific topic?
I think the biggest challenge is convincing people that, and I'm going to put this, I would say, somewhat bluntly, even though they've been doing this their way for many, many years, doesn't mean they've been doing it the right way necessarily. The tools were available and everyone was working with what they had, but there was a period of time where we weren't wearing hard hats or safety harnesses. I always use this example of those videos of people working on the Empire State Building carrying beams around with no safety gear, some hundreds of feet up in the air and just hopping from one beam to the next. And now we use, netting and fall protection, and those improvements to safety, have continued to, bring less risk to projects. And this is really just the next evolution of that. We're not moving the needle that much further, even though it might feel that way. But, this is something that's been a part of our industry for decades, if not over 100 years. And, will continue to be a major point as far as, understanding how to overcome those challenges. The other challenges that, we'll continue to face is convincing people and agencies that the data that they're getting from equipment is going to be equal to the learned knowledge of an engineer who has that significant field experience, who have seen all different types of variations of corrosion or cracking or spalling, and who will be able to understand things like a tap test with a hammer very quickly, whereas it takes a lot of time to invest in equipment that's able to understand the same types of nuance, which is one of the challenges that we have approached by saying, why don't we take a simpler scope and use equipment for that for the time being. So whether that's performing visual inspections, actually one of our clients, and we just received our award letter last week, says that all of the visual inspection on the buildings that we're approaching has to be done with a drone. And once we're able to identify with the engineers on site that there are certain deficiencies within the building envelope, then we will use a targeted approach to bring those engineers up to those sites. And I think that that's really a valuable way to look at the challenges that clients might come back with and say, well, having somebody walk on the ground with a pair of binoculars is a really antiquated way of understanding, and planning where you want to spend that close-up inspection time. And by using whether it's different drones or crawler robots in different infrastructures, it really allows us to change the process and make sure we're putting eyes on the most important parts of the envelope.
And it sounds like there's real potential here for, robot human collaboration. And I think essentially using drones in a building envelope inspection to target your drops or scaffolding or whatever your next course of action is a great example, because it's fairly simple to explain and does add a lot of value, like you mentioned.
Yeah, and I think this also brings up, there's always the conversation of our, robots taking my job. And, I continue to believe that it's actually just changing the way that we do our jobs. Like there will always be a need for, trained engineers to go up and take a closer look, at least for the far foreseeable future. And the value that we bring is, making that a targeted approach. There is so much infrastructure in this country, infrastructure around the entire world, and it's continues to be reported that there's not enough people to inspect it all in the timelines that are required. And so by leaning into technology to fast track the approach of identifying where it's worth spending time taking a closer look and providing those engineers with a really targeted approach is the only way that we're going to get this done going forward. We continue to build more and more and more every day. I mean, I live in New York City. The amount of projects that are breaking ground, is unfathomable, and we're building taller, and it's only going to get more complicated as all of these buildings go through their different local law inspections. So it's exciting to see that whether it's the facade inspection firms or even the Department of Buildings here in New York is leaning into the use of technology to take these more targeted approaches.
And speaking of, using technology to be more efficient in inspection of our ever growing portfolio of assets worldwide. So artificial intelligence is a very common topic and something I think the entire industry is thinking about. But what I think maybe gets misconstrued or isn't obvious is that AI isn't just like a large language model and a chatbot like interface, right? There's all different types of applications of AI, and I want to talk specifically about application to robotics, whether ground or air, so Miles. How is AI improving the capabilities of drones and autonomous systems in engineering? What emerging technologies will have the biggest impact on construction and infrastructure management?
I think you make a great point around, when we break down the topic of AI, it's this very amorphous buzzword that loves to get thrown around in boardrooms and on office floors. And I think the value that we really see in the field of robotics tends to prefer the jargon machine learning, which is to say that we have a problem. And I love to use the example of a little kid learning how to walk, where it's going to keep trying and using the brain to provide electrical impulses kind of at random to the legs. And eventually, all of a sudden, the baby is standing and tries to take a step forward and falls flat on its face and kind of keeps doing that until all of a sudden it's able to take steps forward, walk, run, win an Olympic medal. And the reason why I use that over, sort of the bipeds is the humanizing of this process, I think, is really important for most people to understand really where the value comes in. And so, when we talk about our engineers being the best equipped to understand and identify what the root cause of whether it's rusting or corrosion, moisture intrusion, section loss in the beam, why that's occurring. All of that data feeds into a continuous learning process for whether it's our research and development algorithms for data processing or to the larger set of robotics to continue to learn from the experts in a way that's very systematic and allows for a future where we're able to provide some context to the end user, our engineers or our clients' engineers, to have a good sense of what they're looking at and maybe provide some suggestions. I think the way a lot of people are using like ChatGPT or chatbots right now is as like a source of truth. And really it's a source of suggestions and recommendations. And I think that at least in the AEC industry, where we're dealing with much slower change, which, I kind of prefer, in some ways it can be frustrating, but yeah, I'd prefer the bridge didn't fall down when I'm driving over it. So that pacing I think is appropriate, but it's a matter of making sure that we continue to use these tools to our advantage to learn, what value we need and continue to advance at least in what we're working on in the background, the processing of these huge data sets. I mean, we come back from a project with 300, 400, 500 gigabytes, sometimes even up to a terabyte of photos, video, point clouds, you name it. And that can either take more time than just going out there and taking photos, or we can use efficient processing to help it either maintain or even beat the speed of our engineers sifting through, photo by photo or being out in the field at that high risk. And I think another avenue is really in the equipment that we use. So there is not a piece of equipment that we use in our fleet that is not using some form of AI, whether that's to learn the model of the different motors as they get replaced, whether it's to perform different sensor fusion to improve the stability, control, and obstacle avoidance of our different robots, or even on some of the data processing side, there's autonomy in things like identifying cracks or creating different maps and photogrammetry models. It's everywhere, and AI is the buzzword, but whether it's companies using very large data sets to improve their own processing so that way we as their client continue to receive that value in terms of the reliability of the equipment, the reliability of the data processing output, and the reliability of the sensor models that we work with every day is really key.
And that's a great summary, Miles. And I think you really drove the point home that it's more than just, I think, what, say, the general public thinks AI is, and it's in our hands. It's being used every day, whether or not we actually realize it.
Yep. Like it's likely that, the compression algorithm that we're talking over right now is using some sort of learned model. And the compression algorithm that is feeding this podcast to our listeners is probably also using some version of a learned model. And so, really highlight that it's everywhere. It's it's right here.
Yes, right in front of our faces, and we may or may not even know it. And another point I wanted to highlight from the answer to this question specifically was patience, because I don't know that that's talked about a whole lot, especially for innovative people. And it's really refreshing to hear it, from someone in your position, not because it's not common. I think it would be more common than people would think, but it's not like, you're trying to come in and blow up an entire industry and turn it on its head, right? It's part of that is true, right? I'm sure, with certain processes or ways of doing things, but overall, like you said, right? We don't want the bridge collapsing while people are driving over it.
Yeah, and I think patience, in some ways comes in multiple forms. And there's patience in terms of convincing our clients to move forward. There's patience in terms of how long it takes to gather a data set and annotate it in a way that allows us to work on these models. And there's also patience in terms of what is the future that you're thinking about and talking about. I listen to a lot of the sort of thought leaders in the different tech industries, and I hear them talk about scales of time that are years, decades, sometimes even centuries. And I think it's important when you're in some ways losing sight of what you're working on in the day-to-day to really take that step back and say, okay, well, what is this for and when is this for? And I know that every step that I'm taking, whether it was working this morning or even working tomorrow, building relationships with different clients and agencies, that it's in pursuit of a much grander vision that is, like one of our drone manufacturers says, no more confined space entry. That's a huge, huge promise, but it gives us something to look forward to. And for us, we don't want our people at risk. And that's the vision and the value that we have for our robotics department. Why put a person at risk if you can put a robot in its place? Or, as you might see on my LinkedIn, and I like to say, a robot a day keeps humans out of harm's way. And that is a really core kind of vision statement that allows us to continue to think forward and say, okay, well, are we eliminating a human in harm's way today? Great. We may not be able to, even if the project scope is exactly the same, there might be conditions where we can't use a robot, but we continue to pursue that vision forward and looking at different available technologies, and eventually we see a vision where we're able to sit comfortably in the office and send the robots out onto the job site and work with the data once it comes back in.
And I think another piece that I'm thinking of now, Miles, is the time scale that things are worked on. So, we're in the business of assets, buildings, bridges, etc., which often have lifespans of 50, 100, right? I'm sure if you look out your window, you can see some buildings that have been in place for 100 plus years.
Mm-hmm.
So I think it's important to keep in mind that what the types of things we work on, right? Like 100 plus year service life versus, what you may see in the general media regarding AI. like an app that's a chat GPT wrapper that may be gone in 6 months. And so the change of pace in this industry, I think, makes sense based on the time scale in which these assets serve us. And it's important to not get caught up in the hype of other industries that are working on, I would say, completely different time scales.
Yeah, and I think that also plays into, the data that we have access to. There's an exponential amount of data, being generated every single day online for things like chatbots, but we literally have to wait for things to corrode in our industry. So it's not like we can just create corrosion out of nowhere. I mean, we can apply different chemicals and materials to different materials and force that corrosion. But if we want to see, you know, corrosion on the underside of a bridge like, the Brooklyn Bridge or the George Washington Bridge, like, we have to wait. And that's a real world application where the data is going to be much more valuable to fine tuning a model because there's things like the sun shining through that might cause issues with the camera. And so, is that going to give us more interesting data to train on? And similarly, buildings are getting built at an exponential scale. So there's a lot of newness. And in theory, these new buildings that are going up shouldn't just be like, falling apart within the first few years. So for us to hit the same very large data set and very large scale of readily available and well documented data is going to take more time. And being patient with that and understanding, like you said, the scale of, tens or hundreds of years, like I was reading a report that the concrete that's going into some of these sky rises is like fine for the next 250. So that's a huge, huge number. When we think about, what am I doing today? Oh my God, like this is going to be around for like the next 10 generations of people. And it's also pretty exciting to know that the investments we're making now and the changes we're making to the industry are going to, maybe even push the longevity of these structures beyond that, long
And
after both of you and I are gone.
it really, puts in the perspective, right, of, let's say one of your designers either designing a new structure or designing a repair. It's the stroke of that pencil or pen, or CAD equivalent, let's say, is it could be felt for a really long time. So I think it's important to keep all that in perspective.
Absolutely.
So Miles, I know, let's say, people may have heard in the news some like lightening of regulation on drone use in New York City specifically, right? So that being one example, when deploying drones for engineering applications, what are the key regulatory and operational considerations AE firms must be aware of?
So local laws are really important. New York City, we go through the permit process with the NYPD. Of course, we're going to be, checking our air tables and making sure that we're not in any regulated airspace, or if we are, that we're working with the local air traffic control, either through an auto authorization or some extended version of that to get airspace clearance. And, it's really important for us to also understand what the client's needs are. So every agency that we work with has a different sort of drones policy, whether they require certain things like lane closures or certain safety measures on the drone, certain hours of operation. It's really a case by case basis. And I think for our industry, being prepared for the process or headache of doing so is really important. Goes back to patience. Make sure that you're planning your timelines out longer than you think you need. It's just because they say they'll get a permit to you within a certain amount of time, or they'll okay things within a certain amount of time, doesn't necessarily mean that you've provided everything they need to give you that okay, and that may extend those timelines even a little bit further. And it also comes back to communication. I mean, letting the client know, hey, this is generally what we do for the permits, but this project is particularly unique and there may be some challenges. And, we hope to work together to get all of the documentation that's needed, certain like letters of authorization to be on different property sites. How do we ensure safety for the public? And in some instances, things like, deployable parachutes on the drones, just in case, you have a electrical short. We use tethered underwater robots, and, we always have a rescue plan in place. So while we don't want to send somebody into the water, and that's kind of the ideal, we will need to retrieve our equipment in the event something catastrophic does happen, and being ready for that. I mean, confined space entry is another great example where, we're using drones to fly inside of these spaces where, people shouldn't be, and in some rare cases, we're dealing with technology in the same way that a human makes a mistake. Technology can short out or find itself in like the perfect awkward spot to get itself stuck. I liken it to some of those videos of like the self-driving cars just like not allowing one to pass, and they both just kind of sit there and look at each other and wait for the other person to make a move. Sometimes that's just what happens on site. And being patient and being ready is the most important thing you can be.
And I think there's a lot, a lot of parallels to be drawn with the human experience too. Like from two people meeting at a four-way stop and saying, you go, no, you go. We might be able to resolve it a little bit quicker, but I definitely think there's a lot of parallels to be drawn, right, from what are essentially human-made creations, and just I guess anthropomorphizing that can kind of
Yeah,
help people understand where they're coming from.
yeah, and the good operators will get the job done, and the great operators know what to do when things go wrong. Yeah, I remember like within my first 3 days of buying a drone, some 11 or 12 years ago, it's like first major crash, learn how to put it back together, be patient, get back out there and do the same thing. A baby doesn't stop trying to walk just because it falls. It might take a couple of days before it tries again, but again, humanizing this relationship we have with the technology, I think, is valuable to moving, both people who are interested as well as, the people who might be resistant to robots coming in and, taking our jobs. Everyone uses a phone. We're communicating without being in person, some, hundreds of miles away from each other, and I think that's a pretty awesome thing.
And speaking of that, it's essentially the value proposition that I think gets a lot of people on board with these new technologies and changing the way they do things. And a piece of that is data. And through this conversation, I've appreciated how you've essentially separated the robot from the sensor, right?
Mm-hmm.
And for the audience, right, the sensor is the thing that collects data, and the robot's the thing that gets you to the place you need to go. But how can AEC firms maximize the value of drone or robot collected data, and what role does automation play in streamlining insights into each individual project?
Sure. I think a really unique approach that we're taking with our clients, all infrastructure is on some sort of inspection cycle. And, at least in the current stage, I think there's a lot of value to doing, either the first few inspections manually, but making sure that you're cataloging the data that you're collecting in a way that allows you to look at change over time. We have clients that have come to us and said, well, the only time we get data is once every 5 to 7 years, and the scale at which issues need to be addressed is maybe in the scale of 2 to 3 years. And so we don't know until it's already too bad and too costly, because we can only afford to do this every 5 to 7 years because we have to close lanes and get trucks and the symphony of people required, and I mean, just the permits alone. And, we've kind of taken an approach to say, well, what if we did it a little bit more frequently at a cost that's, even reduced from your once every 5 years, if we look at the same scale of time, and allow you to understand, these changes over time. And that really is a matter of, also working with the, robotics manufacturers to say, hey, this is what we need. This is the value that we want to see. And we, do beta testing and have discussions with the internal R&D teams with some of our equipment and provide that feedback. And they're, yep, we're working on, automated inspections. So you'll go out and fly it once, and we'll go repeat your same path. The next time you need to do it, we'll take photos of the same locations. that you identify in the post-processing software, even beyond what you collected in the field the first time, and use that to continue to provide that sort of ongoing value to the client. And that I think is really the one of the key pieces of automation in our industry. If I need to inspect a building every 5 years, I'm gonna inspect it once, and then our client is not necessarily locked in with us, but hey, all of these points that were issues last time, why don't we go take a look at them again? I get there where I send a team and they press a button, and the same inspection that was done with certain degrees of close up thermal images, different types of applied contact, non-destructive testing data can be collected. And yeah, that's really the goal going forward, is that sort of ongoing process. And we're not dealing with things that's like, all right, well, like, let's take a look and then we'll tear it down. Remember a project in the film industry where I just happened to be chatting with the guys that built a set, and they're like, hey, can you just like go check the screws up on the top and make sure they're still in, when they stood up the sort of facade of the building that they were filming in front. I was like, oh, they're like, oh, that's great, and that's all we need, and we're going to tear this down and move on to the next thing. We're dealing with real built infrastructure, and for a useful life of 100 years, automating the inspection process is going to be vital.
Yeah, that's that, and that point itself is I've heard a mentor of mine, say, hey, if you're not going to do it 1,000 times a year, in this specific example, just don't worry about automating it. And you have to understand the time scale and the frequency of what you're working on and at to understand it. Is just doing it manually the most efficient way. So you don't want to necessarily get lost in you don't want to get lost, I would say, in the bright and shiny object that technology can be. It's just understanding about where the value is really driven and how you apply the technology to do so.
Yeah, and we're fortunate at this stage where we're using almost entirely off-the-shelf equipment. So while it's the most advanced in the world, it's their job to automate it, and our job to continue to identify where they, as a robotics firm, can find value for other clients like us. And because we're using our equipment very regularly, we're putting it into some really challenging environments. We have the knowledge base to provide that feedback that allows them to then spend the resources to do things like flight automation or remote inspection, or like sonar mapping in a very systematic way.
And it's a partnership, right? Just like there's a partnership with you and your clients, there's a partnership with these robotics, let's say manufacturers that you work with, because you can't do it without each other, because you guys are a great source of, let's say, training data or objective feedback from the field. But you of course need their assistance, because we're in the AEC business, right? We don't manufacture robots, so we need all hands to be able to make this type of stuff work.
Yeah, and it's exciting to see the different potential of the same equipment in other industries too. I mean, we're using drones for, like, a confined space drone for doing like large vaults or getting up close underneath bridges. Some people are using it in mining and other industries, whether it's even like flying inside of turbine blades, for example, for large scale wind turbines. And it's really unique to say, here's a platform that moves in this way, and here's a set of sensors that are valuable to this set of industries. Some of the sensors, like some of the, like when I'm talking about the flyability Ilios 3, and I mean, they have a nuclear radiation sensor that I'm never going to use, but it's pretty exciting that this same platform that allows you to navigate in some really difficult spaces, bump into walls and not even think about it, is able to be applicable to those industries. And we're providing our small subset of feedback to, hey, it'd be really cool if it did this, and to see that make its way through the priority chain and come out as a feature is pretty exciting.
So Miles, what skills would you say AEC professionals need to develop to be able to effectively work with and manage robotic technologies in their projects? Because I think the idea of, so drones pretty common, but robots in general, I still think is a new concept to a lot of practicing professionals.
Yeah. I mean, I think it's really a matter of kind of curiosity. Like I think it's really important to continue to say, and I'm actually really grateful because this happens in our firm every day. Hey, I'm doing this and I'm noticing that it's taking me a lot of time and the task is very repetitive. And I'm curious if there's a better way to do it. Or, hey, I'm realizing that the conditions for this project seem pretty unsafe. And while, we're going to put every safety measure in place, I'm curious if there's a way to do this that keeps me on the ground or keeps me out of harm's way. And from our management level all the way down, that curiosity is a really big part of the culture at Gideon. And I think in many ways it's infectious. When you have leadership saying, "Hey, let's try this. Let's see how it goes on this project. Let's meet between our different teams and see if there are upcoming projects or even previous projects that we can look back to and try to do in this new way and figure out if there's value to that going forward is what will drive our industry and industry professionals in the direction of leaning into technology. And it's the case, and unfortunately, often enough where that curiosity leads to nothing. Like, hey, can I get a chatbot that writes me all new legislation around this and gets it passed? I wish sometimes, but um, it just because you have an idea that doesn't come to fruition doesn't mean it was like a waste of time. And working and with firms like ours or equipment manufacturers or even firms that are more old school and having that open mind as to what could I do differently and what could I do on this project differently is really the key to that. And a lot of research. Like one of my favorite things to do is read like very burgeoning research papers for which the math is incredibly complicated, and I in some cases even goes over my head. But the importance of a lot of that is to say, wow, people are working on these really unique problems and the results are looking great in this very sort of sandbox environment. And this could really become something one day, whether it's a different mode of data processing or, wow, we're able to fly a drone with this type of power output that extends our battery life. I mean, like the first drones, right, were like you get like 10, 15 minutes of battery life, and now I'm flying a drone that has almost an hour. And that only comes from innovations in power supply, innovations in battery technology, and the curiosity to say, hey, can we make this any better?
And you mentioned, right, the curiosity. I also like to add creativity to that
Hmm.
because it's being curious about the problems, and then the creativity of, I'm sure you guys have a lot of experience in this, is how do we take off the shelf products or off the shelf components and fit it to our specific use case, because custom builds oftentimes needed, but they can be expensive and time consuming. But if you can be creative with what's at your disposal, it's almost like the sky's the limit.
Yeah, and I think that is a really great word to use. And I think it kind of ties into that sort of like innovative as well, which is, yeah, I remember using something as simple as like a PVC pipe with a camera on it because the drone signal wouldn't get me the reach I needed to turn a 90-degree, into an environment that's, fully signal denied. Like, hey, well, what if we just put a GoPro on the end of a pole and just hang it over? That seemed to do a great job, where we weren't able to, get our equipment to do the same thing. And sometimes it's a simple fix. Sometimes it's, hey, I have this heavy lift drone and I heard about this new sensor that a firm is working on, and it's really valuable to this specific project. Why don't we, reach out and figure out if we can get data input into our technology, store it in an efficient way, and figure out if that's either a new use case for something or yeah, everyone had a great time flying drones. It's really hard to have a bad day in the field when you're out on a beautiful day flying drones. Even the cold days are fun. Yeah.
Absolutely. And Miles, it's really been a pleasure getting to talk to you about pretty much everything that you're working on and how it applies to our industry. But what final piece of advice can you give to AEC professionals that are looking to embrace robotics and drones to improve their projects and stay ahead in the AEC industry?
Yeah, I think there's this sort of like improv game called Yes and while you're sitting down and trying to figure out whether or not this is right for you, I think the way the game goes is when somebody asks you a question, you have to say yes and then kind of continue with whatever it is that they're making suggestions for. And well, can we use a drone for this? Yes. And can it provide us value? Can it cause damage? Can it hinder our process in any way? And just continuing down this rabbit hole of questions is really important to exploring all of the different avenues for which there are both benefits and risks associated with drones. We're not doing every single project of ours with our equipment, but we're doing enough where we're starting to see this shift both with our clients and our firms that is making the investment worthwhile. We have a pretty expensive fleet that we started with because we wanted to make that investment and be ready for when our clients finally decided to change their tune. And we're fortunate enough to have been able to do that, being an established 20-something-year-old engineering firm. And instead of kind of operating from this place of fear or anxiety around what the future holds related to drones and robotics, we just kind of said, yes, this is going to be a part of what we do, and we'll continue to figure it out along the way. Like a great plan is only 70% of the final solution to the problem. And once you kind of get 70-ish% of the problem solved, you kind of have to just go out and figure out the rest on the day by day. If you wait until you're 95% of the way planned, everything that you had planned, ready to go is now obsolete because that's an exponential amount of effort to plan out to that fine detail. Yeah. And like, I happen to see today is World Robotics Day, which is pretty exciting. So, it feels kind of appropriate to be talking about this on a day like today. And I've seen a lot of really great posts even this morning, and people leaning into the excitement around it. I would say like it's okay to be excited even if your colleagues or your clients aren't. And that excitement will continue to grow, within the people around you. And at some point, someone's going to look at the dollars and cents and realize that this is really the right way to go about it. We can do as much convincing as we want until we put together a proposal and people go, oh, wow, that really is a major difference. And once they see it in their terms, and whether their terms are safety or better data. We had a client last week, I would say maybe like a 20% joking, 80% serious. I don't care how much good data costs. I need good data. It's just a wonderful thing to hear. And other people who are like, my job is evaluating the cost of risk. And there's a huge financial burden associated with risky procedures. And someone else is like, I don't care as long as you're going to save me money. And so, yeah, like everyone has something they care about. I guess asking yourself the same question, like, why do I care about drones and robotics?
And what I heard there, Miles, is it's being the change you want to see. It's bring the future forward and creating that own future for you and your firm, and that it's figuring out what people care about. And those were some great examples of clients, for example, like you said, money, time, risk, and just being able to translate the benefits of drones, robotics, and any technology into those terms that the person who signs the checks cares about is really important no matter what you're doing.
Yeah. And persistence, like we talked about patience, but the other side of that is persistence. Like keep pushing. We have clients who are like hitting a brick wall so thick I don't even know that there's another side of the wall, and eventually we'll break through. And it's going to take kind of like one domino to fall, and sometimes that's not going to go all the way through, and you're going to put a lot of effort into something that doesn't materialize, but kind of getting up the next day and saying, all right, well, what else can we work on and what other exciting opportunities are there. And people tend to come around to these things once everyone else starts to get on board. So yeah, patient and persistent.
And I like to call it, it's a term I learned a long time ago, aggressive patience. And then if you have time, look up the theory of natural harmonics, which basically is a simple way of saying, like an example is you can't bake a cake at 800 degrees and expect it to come out in half the time, right? Some things just take as long as they take. Some clients will get back on their own timeline, which is why it's good to have a lot of irons in the fire. So while some cakes are baking, you could start making some others from scratch. How about that?
Yeah.
Miles, thank you again so much for taking the time to join us today. If the audience wants to reach out to you, ask you questions about anything we discussed today, what is the best way for them to reach you?
LinkedIn is a great way. I'm tend to be pretty active in responses to messages there, especially people who are interested. Our website, GedeonGRC.com, which I'm sure will be linked here in that podcast, is another great way to take a look at what we do, and look forward to connecting and bringing this industry forward together. One of the things that I've continued to value most about being in sort of the drone space is it's a pretty small community and everyone is really excited to share what they're learning. We're all a bunch of tech people that get really excited when we can do something amazing, and I love seeing other people share what they're working on and sharing the insights that I have. It's going to take all of us working together, and look forward to hearing from everyone.
Really well said. Miles, it has been an absolute pleasure to get to sit down with you today, and to the audience, until next time, I wish you the best in all your engineering and technology endeavors.
Great. Thank you, Nick.
Absolutely, Miles. Take care.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.